let's look at two more data structures in Python, namely sets and dictionary. Let's start with sets. So what is a set? A set is just a collection of unordered items. So we can create an empty set by this command. We can create an empty list by this command. And similarly, we can create an empty tuple. So this is one way to create an empty set. If you directly wanted to describe the data of the set, you can use curly braces and 0, 1, 2, 3. So this is how we can actually create a set of 4 items. And one more thing, the items in the set should be unique. Even if it is not unique, it will create a unique set of items, even if it is repeated. So let's see if we print the set, what happens. See, this was the set. But even if we had repeated items, still it should be unique. See, even if we have 2, 3, finally there's only 1 3 here. So always all the items in the set are unique. We can also convert a list to a set if we wanted to. For example, let's say this is the list. So we can again use the set function to convert the list to a set. And we can run it again and see it works. So we can also add an item to the set. So the command is add. So S is an object, which is a set. S dot add. Let's say I wanted to add 10 to the set. This is how we will do it. Let's check. See, 10 has been added to the set. Although it looks like it's sorted, but there's no ordering in the set. There's no guaranteed ordering in the set. So suppose I wanted to check if some element is in the set or not. So what we can do is, let's say 9 in S. So since 9 is not in S, it will return a false. See, it returns a false. Let's see if we check for something which is in the set. 10 in S. See, 10 is in the set, that's it. So let's say 10 is not in set, just the opposite. So now it's false. There's another function to remove an item from the set. It's called remove. Let's say I wanted to remove 2 from the set and just print the set. See, now we have removed 2 from the original set 0, 1, 2, 3. So this also provides some operations on sets. We will actually look at it in detail when we move to probability theory. But just for the sake of functionality of sets, we will see how it works. So for looking at operations on set, we need at least 2 sets. So let's say S1 is 1, 2, 3, and 4. Let's say S2 is 3, 4, 5, and 6. And we create a new set S3, which will be some operation on set S1 and S2. So let's say I have a couple of functions which can be there. So first function we want to look at is union, and then we print S3. So what is it doing? S3 is the union of set S1 and S2, right? So the final set will be a set where every element in S1 and every element in S2 will be in the set S3. So let's look at it. See, S1 has 1, 2, 3, 4. So S3 has 1, 2, 3, 4. S2 has 3, 4, 5, 6. And S3 has 3, 4, 5, 6. So you understand what is a union? A union of 2 sets will be a set where every element of set 1 and every element of set 2 will be in the set 3. So the next operation is intersection. So intersection is something where S3 will have elements only from set S1 and S2 when those elements are in both S1 and S2. So let's look at it. Basically the overlap. Let's look at it. 3 and 4. So 3 and 4 are the elements which belong in set S1 and S2 both simultaneously, right? So this is intersection. Another one is a difference. So what happens is, how is intersection difference different, right? So what difference does is it will remove elements from S1. So it takes S1, creates us like a set, then it will remove the elements of S1 only from S1, which is also in S2. So let's look at it. See, so what happens is 1, 2, 3, and 4. This is S1, and 3, 4, 5, and 6 is S2. So when I take S1 difference S2, so there's overlap of 3 and 4 in both, right? So we will remove everything which is overlap with S2, which is 3 and 4. So the answer is 1 and 2. So one way to see is we will remove elements of S1. So it's more like S1 minus S1 intersection S2. If you want to like look at it that way. Another function is disjoint. It returns a Boolean value. So now the return element is not a set, it's just true or false. It just says that whether S1 and S2 set are disjoint or not. We'll look at what is the meaning of disjoint when we look at probability. But for now, let's just take it at face value. So S1 and S2 is not disjoint. So disjoint is basically that nothing kind of, so all the elements are different, right? That's one way to look at it. So when the intersection is 0, it is disjoint. But because we have 3 and 4 as intersection, so this is not a disjoint pair. So that's why it returns false. So let's say if I didn't have 3 and 4 here. Now there's no overlap and the disjoint property is now obeyed. So now S1 and S2 are disjoint. See, now it's 2. Is subset. So there's another function called is subset. So what it means that is S2 a subset of S1. So obviously if in current example it is not. Let's see. But what if it is? Let's see what happens now. Okay, the directionality is C. So because S2 is a subset of S1, so S2 is a subset of S1, so that's why this is true. So yeah, I mean, this is all about sets. It's very helpful when we use sets in a way that if you want to have a collection of unique unordered items, you want to very quickly check whether an item exists in a set. In these kind of things, set is useful. Let's move on to dictionary. We can create an empty dictionary by this function called dict. This is an empty dictionary. So if we print it, let's see how an empty dictionary looks like. See, it's again curly braces. But what is different in a set and a dictionary, apart from a curly braces, is that it's a named indexing system. For example, let's say I had a list 1, 2, 3. So we have a list of length 3 with items 1, 2, 3. So we can access the items in the list by an index. So 0 is an index here. So the index of 1 is 0, the index of 2 is 1, the index of 3 is 2, right? So L of 0, right? This is basically indexing, and here the index can only be a number 0, 1, 2, right? So let's look at it. See, so L of 0 is 1. Similarly, L of 2 would be 3, right? So the point is that list is a index-based data structure where index can only be an integer, 0, not even integer, like non-negative integers, 0, 1, 2. But yeah, in Python, negative is also allowed, so it's an integer. So yeah, so what dictionary provides us is like the index can be a string, right? So let's look at it. So what we can do is that we can actually define an index which is called a key. So D name is the, so now let's look at how D looks. See. So now we can see how it is different from a set. Basically, it has a pair of items. So let's add one more item. So let's say country is India. Now look at the results. See, so what is really happening is it's a named index, and every entry in the dictionary is a pair of key and value. Key colon value. Key colon value. So this is a dictionary which just gives me named retrievals, right? So let's say I wanted to retrieve my name now. So I just access it this way. And how it is different from a list you can see now, right? Because now the indexing can be a string as well. See? So when I access name, it gives me the value. So basically a dictionary is a collection of key value pairs. One more thing, basically we can do few more things. So if I wanted to look at all the keys in the dictionary, see, so d dot keys returns a list of keys. Similarly, if I write d dot values, it will return me a list of values for the corresponding keys, right? And there's another one called items. So that gives like a list of tuples, key value, key value, key value. Let's look at it. See, name Devendra, country India. So key value, comma key value. So it's a list of key value items, and this is all about dictionary, and it is useful in many ways. We will look at it. We have already seen that if I just wanted like a key value kind of a access. One more thing about dictionary is that the amortized time complexity to retrieve an item, however number of items there are in the dictionary, is constant, O of 1. So we can use dictionary for really fast retrieval and lookups. So one more thing, if you wanted to know the number of items, so length is a function actually which is shared among all data structures. It tells you the number of items in the list, number of items in dictionary, number of items in a set, number of items in a tuple, and so on. See, so the length of D is 2. So one more thing we can do is like we can check for a key. We have name, country, but we don't have the gender. So we can check whether gender is in the dictionary or not. So gender in D. And it will false because it's not there. But if I try for name, it is there, so it should be true, right? So if I wanted to check for a key in a dictionary, we can use name in D, right? We can also like iterate over all the keys using a for loop. So let's say I do a for key in D, I'll print key and access a dictionary with that key. Let's look at it, what it does. See, so dictionary is now iterating over the tuples of key value. The first key value is name Devendra, second key value is country India, and so on, right? Another interesting use of dictionary is when we can use a list of dictionary. That is useful. List of dictionary. So first item is an empty dictionary, second item is an empty dictionary, third item is an empty dictionary. So now what we can do is we have a list of dictionaries, and each item could be an entity, like a person. It could be like a name, first person is Devendra, country, let's say is from India. Now let's say the second person is Roshan, he is also from India. Third person, let's say, is from the US, and let's say his name is Ravi. Let's say we have only three people. So now we can see that we have a list of dictionary, and each item here is a dictionary which represents a person, right? So let's say if I wanted to go through this list and print the name and the country, right? So let's see how we can do it. So we will iterate over the list, and it returns as a dictionary. Now we can access the dictionary. So what we can do is we can use an F string, and we can say the person, the name, lives in the country. We have to escape the quotes because if I open the quote here, it closes here, but actually it should close here. So we have to escape all these quotes. So how we do it is like this. I hope I'm right, but let's see. We'll know very soon. Another way is using single quotes, but let's see if it works. Okay. So I mean, this is a simple solution. See? So now what is happening is we are accessing the list one at a time, and each item is a dictionary, and we are accessing the name and country in the dictionary. So name lives in country, which means that if I take an instance, Deven lives in India, Roshan lives in India, Ravi lives in US. See the results. Deven lives in India, Roshan lives in India, Ravi lives in US, and it's exactly what our dictionary tells us. So this is all about dictionary. Before I move on to other topics, let's just quickly look at a couple of assignments. So one way to do assignment in Python is this. So what it is doing is basically D and E will be equal to 1. So this is a type of assignment. Let's see. See it works. Similarly, there is a multi-assignment thing. We can do D, comma, E, comma, F is equals to 1, comma, 2, comma, 3. And we can print D, E, F, and it works. Let's say I wanted, so there are also like very nice looking code uh, which we can write. Let's say A is equal to 1, B equal to 2, and I want to swap the values of A and B. So one way to do it is like temp is equals to A is equals to B is equals to temp, and then we can print A comma B. So earlier A and B was 1 and 2. So after this swap, it should be 2 and 1, right? Let's see. See? So with these three lines, we were actually able to swap the values of A and B. But Python also has a syntax which will help us to directly swap it in one line of code. A B is equals to B A. It's obvious, right, what it is doing. So A takes the value of B, B takes the value of A. And the same result. So we can do this. So yeah, I mean, for now, I think this for this section, I think it's enough. We will move on to comprehensions. So we'll look at set comprehension, list comprehension, dictionary comprehension, generator comprehension, right? Let's look at comprehensions, namely list comprehension, dictionary comprehension, set comprehension, and generator comprehension. So let's say I wanted to create a list with first 20 whole numbers. So I create an empty list. I loop for range 20, and I can append each entry coming from the range 0 to 19 in the list. See, our output is 0 to 19. So what we have done here is we have created a list and filled it with items. In this case, the item is 0 to 19 by using L.append. So how list comprehension can help us is it can help us create a list in a very concise way. Let's look at that. So line number 7 is what is called list comprehension. So what it is doing is that the list is comprising of I, and the value of I is coming from this second part for I in range 20. Let's look at it, and we will see the same results. See? So a list comprehension gives us a very concise way to create a list, and this is mostly used in simpler examples, less complicated examples. So there's one more thing we can do as an extension to this so that we understand the syntax completely. There's also a conditional part in comprehension. So we can continue and say if I mod 2 is equal to 0. So now what it will do is it will collect all the i's which this for has created and add a condition to it. So finally this comprehension will just have even numbers. Let's run and see. See? So the above list was a full list without a condition. And with the condition, we can see that all the odd numbers are gone now. We only have even numbers. So this kind of concludes the list comprehension part. Now let's look at dictionary comprehension. For that, let's start with a list of words. So let's say the list of words is hello, world, I am here. This is my list. I could have created this list by just doing this, right? I could have a string which just says, okay, hello world, I am here. Dot split on space, right? So we are kind of using the previous concepts we had, and let's print the words and make sure it is correct. It is correct. So basically now we have a list of words, and I want to create a dictionary where the key of the dictionary is the word, and the value of that key would be the length of the word. So let's create a dictionary. So let's do it in the traditional way. So I create an empty dictionary. Now I loop over all the words in the dictionary, and I create an entry for every word. Okay, so let's run it and see. So now we can see that every word is the key here in the list, and the length of the word, length of hello is 5, length of world is 5, length of I is 1, length of an is 2, so on. So this is a dictionary we wanted to create where we enter the word and it gives us the length of the word. Now let us look at how we could have achieved the same with the list comprehension in a concise way. So similar to list, we will use, in list we use square brackets. In a dictionary, we will use curly braces. And let's see how we could have achieved the same thing. So key colon value is always how the dictionary is composed of. And we just now do the comprehension thing which we just saw in the list for W in words, and that's it. And when I run this again, you can see the result is the same, exactly the same, right? So line number 9, this is dictionary comprehension. I just wanted to show the syntax of one thing. Because we already have a dictionary now, I could just create a list of words, and so let's say my words is equals to d dot keys length is equals to d dot values. The first thing I wanted to show you is the zip command, what it does. So we do zip words and lengths and see what it does. Let's not change the input again. Let's create a list out of it. Okay, so what this zip is doing is that it creates tuples out of two lists here in this example. So it will take the first word in this list and first length in this list, create a tuple out of it, which is hello and 5. Then it will take the second item in this words list, the second item in this lengths list, and create a tuple out of it, which is world 5, and so on. So this is what zip does. And just for the sake of uh, completion in terms of syntax of list comprehension, uh, let's create that word dictionary again. What I will do is key colon value for key comma v, which is key value in zip words and lengths. And so the zip part we have already seen just now. So we know what it returns. It returns a list of tuples, and we just uh, pick one tuple at a time in the list and create a dictionary out of it, because the tuple is k comma v, key comma value. Let's look at the dictionary we just created with this new syntax. Let's run it again. See, again we have a dictionary with words and length of words as key and value. So this is the syntax. So I think this is all about dictionary comprehension. Let's move on to set comprehension. So for set comprehension, I want some duplicates so that we can see the deduplication in the set, right? So let's say L, which is a list of strings, and let's say I add some name of the books. That is my favorite books in machine learning, right? So can I have probabilistic machine learning and introduction. The second book is same name, it's just called Advanced Topics. There's another book, Machine Learning in Python. It's not my favorite book, it's just a name. And pattern recognition and machine learning. So we have 4 books here, and obviously we could do it with for loops and all just by using the set dot add command for each word in each book. Okay, let's do it anyways. So, or maybe not. So anyways, the point is what we can do is we can create a set of all the words, and whenever there's repetition we will not repeat it because set by default has that behavior. So let's say we write tokens equals to w dot lower for s in L for w in s dot split on space range tokens. See, so the difference between set and list comprehension is both have set and dictionary comprehension is both have curly braces, but in dictionary comprehension we have a colon when we create the values. Here we just have the item. It doesn't form key value kind of thing. It's just there, one word at a time. Another example here for list comprehension where we can see nesting, 2 for loops. So what is happening here is that we first take one sentence at a time from the list L, and for each sentence S, we split the sentence on space, and that gives us words W, and that W we use dot lower because sometimes learning has a small L, sometimes learning has a capital L, and we truly want to create tokens which are unique. Let's run it and see. See, for example, machine learning is occurring 4 times, but here you will just see that machine and learning occurs only once. Probabilistic is occurring 2 times, it's only once, and so on, right? So this is one example of creating tokens from a lot of sentences, and this is how you create a list of tokens using sets. So right now we are printing a set. We could also convert this set to a list if we wanted to. We're using the list function, and then the output will be list. See, this is square bracket because it's a list. Either ways, this is very useful when you do an LP kind of things. When you really want to create uh, a list of unique tokens. So let's move on to generator comprehensions. So let's look at an example. So my generator is equals to square of. So it's very similar to list comprehension, but generator comprehension is just different in a way that list comprehension has square brackets, generator comprehension has round brackets, and while runtime it operates in a different way. I'll explain just in a minute, but let's first complete the command for x in range 1 to 11 if x more to is equal to 0. So from list comprehension perspective, if I just had square brackets, then we print this, what will we see, right? Let's see what we will see. So in list comprehension, when we print the list comprehension, it gives us a list which just says that in the range of 1 to 11, it creates the square of it. Okay, there's this condition also, but the point is that it first creates a list of even numbers, then squares them, and then creates a list, right? Let's change the square brackets to round brackets and see what happens. See, it didn't print anything, it's a generator object. And I'll comment more on it just in a minute, but let's complete the code first for SQ in gen print SQ. Okay. So we can see the results here. The answer is the same, but how it runs is different. In list comprehension, when we had a list comprehension in line number 7, it created the whole list in line number 7 only. And when we printed in line number 8, we could see the list. But in generator comprehension, it creates a generator in line number 7. When we print a generator in line number 8, it doesn't show me the list. It just knows how to create the list. But when I iterate over the generator, it returns one item at a time. And while I'm iterating the generator, it is actually creating the value there in time. So let's say if I had like 100 million items, if I had a list comprehension, it might get stuck at line 7 for a while to create that list, have that kind of memory to have that list in line 7 only. And that's a huge burden on the program and the hardware you are running it on, because for example, in this simple example, even if it was from 1 to 100 million, you don't need to store everything in the list before you need it. So you could have generated just one at a time, right? So the generator is something which doesn't generate all the values when we create that. Only when we use the generator, at that time it just creates one value at a time and returns it, and that's how generator is very efficient. And forget 100 million numbers, right? If you had like 10 million images, you cannot load 10 million images in a computer of a reasonable size, right? I mean, which you can afford, right? So a generator is something which can help you, like it might just retrieve one image at a time while you are using it, or 10 images at a time while you are using it. and that's how it's more efficient. So this is all about generator comprehension. Later on, we will look at what is a generator and how to create custom generators. For example, can I create a generator which returns one data point at a time if I had like 100 million or 1 billion data points? So we'll look at how to create a custom generator. And even if you don't cover it in Python tutorial, eventually when we look at PyTorch, there we will need that thing. So either ways we will learn it sooner or later in this program. So yeah, this is all about comprehensions.